Hello everyone, welcome to my YouTube video to help guide you through the lesson today for those of you that are at home with quarantine. I'm going to start with the warm-up here, but what I would recommend before watching this video is that you try and work through as much of the warm-up as you can on your own, just like you were in class. I usually give you the first few minutes to just work through the warm-up and try to attempt the problems on your own to kind of see what you know and what you don't know. Okay, so if you haven't done that already, pause the video and go ahead and try and work through this, see if you can make sense of any of it. And then when you are done, go ahead and resume the video. All right, so let's go ahead and start talking about this first part here. It says consider the function, and we've seen this notation before. It's read f of x, right? So we read this as f of x. It is not f times x. That is not what this means, okay? It is f of x, and it denotes a function. And a function is kind of like a machine where we put something in and we get something out, right? We've talked about this before. So when we see this notation, the letter that we see here, this is the name of the function. So when it asks, what is the name of the function? We say the name of the function is f, all right? And then it asks, well, what is the input of the function, all right? The analogy to that I like to use in class before was the hamburger factory, right? Where the input is a cow, the output is a hamburger. So these functions are kind of the same. We put a number in, we get something else out after we do something to the number. So the input of the function is whatever is inside of the parentheses. So right now, with the way that this is written, the input of the function is x, okay? And we can see x right here, and this is what we do to x, right? So we're going to put x in, and then we do stuff to it, right? So now let's change the input of the function to 3, right? So now instead of saying f of x, we're going to say f of 3 equals, right? And then wherever I see an x, I also need to replace it with a 3. So I'm going to say 5 times 3 plus 2. All right, so this is what we're doing. The 3 has replaced the x. So if I do this order of operations, right, 5 times 3 must go first. So that'll be 15, and then 15 plus 2 is 17, right? So we can say f of 3 equals 17. So we put a 3 in, we got a 17 out. All right, so let's go to this one, right? This next one says, for a function named f, which statement below shows an input of 3, right? So we want an input of 3 and an output of 17. All right, so if I'm looking through these, this one shows a function named f, right? Because we see the letter f there. The number inside of the parentheses is 17, so the input would be 17 on this one, but we wanted an input of 3. Okay, so go to the next one here. We have a function named f. The number inside of the parentheses is 3, so that's an input of 3, and an output of 17, right? So the number on the other side of the equal sign, right? This is the output right here. That is 17. So this one matches with what they were asking. If I look through the rest of these, right, look inside the parentheses here, the input is not 3, it's x. Here, the name of the function is wrong, right? It's not f, it's g, and then same thing with this one. So b is the one that shows a function named f with an input of 3 and an output of 17, right? So let's take a look here, and this is kind of what we're going to be dealing with in Module 3. We're going to be dealing with these things called sequences. So this is a sequence here. We have a sequence of 1, 2, 4, 8, and the question is, well, the first question is, what are the next 3 terms of the sequence? So we kind of have to figure out what is going on here. How are these numbers growing? And so we go from 1 to 2, then 2 to 4, then 4 to 8. And hopefully, as you went through the warm-up by yourself, you were able to kind of figure out the pattern that was going on with these numbers, okay? And we should have noticed that they are essentially doubling each time, right? So if I go from 1 to 2, we're essentially multiplying by 2, right? And then if I go from 2 to 4, we're multiplying by 2 again. And then if I go from 4 to 8, we'll multiply by 2 again, right? 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and then we could continue the sequence to get the next 3 terms, right? So I would, to find my next 3 terms, I would do 8 times 2, which would be 16, then we would do 16 times 2, which would be 32, and then 32 times 2 is 64. All right, and then here it's asking us to describe what the sequence is doing. So just in words, describe what it's doing. And when you describe it, try and describe anything mathematical, right? So we had described the pattern as being a multiplication of 2 or a doubling pattern. So I would say the sequence is multiplying by 2. Okay, and then it says here what term would come before 1, right? So here's 1 in our sequence. So the term that would come before it, if you can imagine another term that came before 1, right? And we don't really know what it is. Now, what we do know is to move forward in the sequence, we had to multiply by 2. So if moving forward required us to multiply by 2, moving backwards would require us to do the opposite and divide by 2. All right, so if I do 1 divided by 2, we would get 0.5, right, or 1/2. So you got to kind of think like what would come before that first term. And that first number that you see in the sequence, that is always the first term. And in this case, it is 1. So going backwards in the sequence would require us to do the opposite of what made it go forward. All right, so last one here, what would be the 30th term? And so you would essentially have to complete like this sequence. You would have to keep it going 30 more times right now, probably with what you know. It's just to continue the sequence until you get to the 30th term, which is a really tedious task. So I'm actually not going to do it in the video. If you did it, great, but the whole point of this unit is to kind of show you, like, if we do run into patterns like these, would there be a quick way to find that 30th term? All right, and that's what we're going to be learning about in Module 3 is to tackle problems like this where we might be looking for you know, a number way down the line in the sequence, and is there a quick way to find it? So one of the many things we will explore. All right, guys, hopefully that was helpful for the warm-up. I would go ahead and move on to the notes now. All right, bye.